Hello, geometry folks, and welcome to Solving Right Triangles. So today we are going to put it all together, everything that we have learned for this chapter. So you will need your notes, a pencil, and a calculator, and we'll get started. The first thing you need to do is you need to write down this definition for me. The definition to solve a right triangle. It means that you have to determine the measure of all 6 parts. You find all the lengths of all 3 sides and the measure of all 3 angles. So if I give you a triangle and I give you a couple of pieces of information, you've got to go ahead and find all the rest of the information, and you will then have solved the right triangle. All right, let's do a couple of examples. So here we go. Example number 1 says solve the right triangle and round the decimals to the nearest tenth. Okay, so we want to remember to round to the nearest tenth when necessary. Okay, so I want to find all the sides of this triangle and all the angles. So I'm just going to go ahead and write down angle D, we already know is 25 degrees. We know angle F is 90 degrees. And I think we can find angle E by taking 180 and subtracting 90 and 25. Now, are there other ways that we can find angle E? Certainly, but sometimes we're just going to go ahead and do the easiest approach we can. So 180 minus 90 minus 25 is 65 degrees. So we have now found all the angles of this triangle. Now the next step would be to be able to find all the sides. Okay, so we know that side DE is 13, and that is the hypotenuse because it's across from the 90-degree angle. I know both angle D and E, so it doesn't really matter to me where we stand, but since the 25 is already here, I'm just going to go ahead and put myself at D. And if I'm standing at D, this side is opposite and this side is adjacent. All right, so now I'm going to go ahead and use sine or maybe cosine to find my opposite and adjacent sides. So let's go ahead and find the opposite side. That would be so sine of 25 is equal to side FE over the hypotenuse, which is 13. So take sine of 25 in your calculator and put it over 1 and cross multiply. So sine of 25 times 13 would be side FE would be, let's see here, if I put that in my calculator, I get 5. Rounding to the nearest tenth would be 5. So FE, segment FE, is 5.5. Okay, now if we know the opposite is 5.5, there's a couple of things we could do here. We could use the Pythagorean theorem and find the third side, or we could go ahead and use trig again. Well, I'm just going to go ahead and use cosine. Cosine of 25 is equal to DF, segment DF, over hypotenuse, because it's adjacent over hypotenuse. And then I'm going to go ahead and put this over 1, cross multiply, and DF would be equal to the cosine of 25 times 13, which would be 11.8 rounded to the nearest tenth. And so then DF segment is 11.8. Okay, and so now I have found all the angles and all the sides, so I have solved the right triangle. Okay, let's go ahead and do another example. All right, in your notes, let's go ahead and write this down. We're going to solve this right triangle, and again, we're going to round to the nearest tenth. Okay, here we go. I got to find all the sides and all the angles. So we know Oh, we don't know angle A. We don't know angle B. Angle C is 90 degrees. Okay, and then we need the sides. So we know AB is 12. We know CB side is 10, but we don't know side AC. Okay, so we're going to have to do a little work here. I'm going to go ahead and find angle A, okay, or angle B. It doesn't matter which one you do. I'm going to change my mind here, and I'm going to go down to angle B because angle A has stuff by it. So I'm going to put myself at angle B, and I am going to find this angle by using the sides that I know. The side 10 is adjacent to angle B, and H, the hypotenuse, is 12. So I am going to use cosine of angle B is equal to cosine is adjacent over hypotenuse, which is 10 over 12. And then remember, when we're looking for an angle, we use inverse cosine. Okay, so we'll put inverse cosine of 10 over 12 in our calculator, and we will get angle B is equal to 33.6 degrees. So angle B is 33.6 degrees, rounding to the nearest tenth. So now we've got a second angle, and now to find angle A, we could go ahead and do 180 minus 33.6 minus 90, and that would give us 56.4 degrees. All right, so now we have some angles going on. And we know this one here is 33.6. All right, now let's go ahead and find side AC. Well, there would be a couple of ways we could find AC. AC is the opposite side compared to where you're standing. So you could do some sine. You know, sine of 33.6 is equal to opposite over hypotenuse. That would be completely fine. I'm going to go ahead and use the Pythagorean theorem. But either way will work. So you have to kind of decide how to get the sides and angles that you want based on the information that you have. So let's go ahead and just practice the Pythagorean theorem. A squared plus b squared equals c squared. My a is 10, so 10 squared plus b squared is the guy that I'm looking for, and c squared is my hypotenuse. 100 plus b equals 12 squared, which is 144. Sorry about that, 144. Subtract 100 from both sides, and b squared equals 44. And square root both sides, and I get b is equal to, rounding to the nearest 10, 6.6. So the length of AC is 6.6. Now remember, you could have done the sine of 33.6 is equal to O over 12. But if you calculated the 33.6 wrong, then AC would be wrong. So I try to tend to do things based on the information I have that will cause the least amount of errors. So that's all I have for today. And thanks for listening and taking good notes. And we will see you again.